but often they're not very useful in the laboratory, right? So for example, even if we know how many moles we need, we can't really measure moles. What we can measure is mass of something. So we need often to calculate mass to mass conversion. So for example, let's say I have this chemical reaction I need to consider. And I am given that I have 32 grams of this. If I start out with 32 grams of this, how many grams of ammonia will I make? This chemical equation doesn't mean that for every 1 gram of nitrogen, I get 2 grams of ammonia. That's not the ratio, right? The ratio is actually moles to moles of something. So if I start with grams, I can't just use this chemical equation as is. I first have to relate it into moles first. Okay, so the first step, if you're given grams of something, let's say a gram of A, what something is, you have to first convert it into moles of A. Okay? Once you have moles of A, then you can relate that to moles of B. Okay, how do you relate moles of A to moles of B? You can convert moles of A to become moles of B using the balanced chemical equation, right? So using the coefficients here. So using coefficients. Once you have the moles of B, the last step is to convert that into grams of B. Okay? So how do we do that? Let's fill in this gap here and this gap here. How would you convert grams of A to moles of A? Using what? What number we know converts between grams and moles? The molar mass, right? But particularly, the molar mass of A. Okay, what about this one? What converts between moles of B to grams of B? The molar mass of B. Okay, so every time if you use this kind of sequence, I call it the grams to moles to gram mantra, it will guide you in the right direction. So let's solve this problem. Again the problem states, if I have 32 grams of nitrogen, how many ammonia will I create? Okay, so if I start with 32 grams of nitrogen, grams of A, I have to go to moles of A into moles of nitrogen. Again, we need the molar mass of N2. So the molar mass of N2, let's do this on the side.
Nitrogen is 14.01 grams per mole, and there's 2 of that. So times that by 2, that's 28.02 grams, right? So, and that's per mole. Okay, so
that means it's 28.02 grams of nitrogen is in 1 mole of nitrogen. Again, that's why we learn about unit analysis. It's going to really guide us. Grams of nitrogen will go away. Next, we keep on going. We are done with this step. Let's go to this step. To go from moles of A to become moles of B using the coefficient. So I asked myself, what is the relationship between nitrogen and ammonia 1 to 2? Right? So 1 mole of nitrogen will give me 2 moles of ammonia. So check out that. And also knowing that units are canceling out. Lastly, now we know how many moles we have of ammonia, but that isn't the question. The question is how many grams of ammonia. So we need to relate that by using the molar mass of ammonia. So we have, let's do a molar mass of ammonia.
Again, nitrogen is 14.01, hydrogen is 101, roughly I'm rounding to 100. There's 3 of that, times that by 3, that's 3.03, right? So adding these 2 numbers, you get 17.04 grams per mole.
Okay, so for every 1 mole of ammonia, you get 17.04 grams of ammonia. Okay, moles and moles cancel. The last unit here is grams of ammonia. Again, that's unit analysis telling us we are on the right direction. So then you just go to your calculator, punch in 32 times 2 times 17.04, divide that by 28.02. And so I get 38.9. Let's just double check that.
32 times 2 times 17.04 divided by 28.02.
Yes. And there's only 2 sig figs here, right? 1, 2 sig figs. There's 1, 2, 3, 4 sig figs here. There's no sig figs here. There's 4 sig figs there. So answer is 2 sig figs. So this should become 39 grams of ammonia. So let's do some questions to check your understanding. Okay, so our first checkpoint question here asks, how many grams of magnesium are needed to react with 16 grams of oxygen gas based on the following reaction? Okay, so again, we are asked how many grams of this guy if we are given 16 grams. Right, so grams to grams, then you automatically go to your mantra of grams to moles to moles to grams. Okay, so we start out with grams of oxygen. 16 grams of oxygen. First up, grams of A to moles of A using molar mass. What's the molar mass of oxygen? I've already calculated over there. The molar mass of oxygen is 32.00 grams of oxygen for every 1 mole of oxygen. Okay. Unit analysis says grams, oxygen goes away. Check off that box. Now we have moles of oxygen. We need to go then to moles of B. In this case, moles of magnesium. Okay, so using our coefficient is a relationship between 2 to 1. So for every 1 mole of oxygen, we need 2 moles of magnesium. Okay, so moles of oxygen goes away, telling us that we have done that step successfully. Lastly, we need to go to grams of magnesium, so moles of B to grams of B using the molar mass of B, or in this case the molar mass of magnesium, which is 24. Oops. You can't put 24 down there because it can't count that with a mole, right? It's the 1 mole of magnesium is 24.31 grams of magnesium. Again, moles magnesium cancel out, giving us grams. We did that step successfully. Putting us into our calculator, we should get 16 times 2 times 24.31 divided by 32.00 is 24.31. In this case, we have only 2 sig figs, so it comes out to only 16 grams, 24 grams of magnesium. Answer then would be D.